All right, welcome back to part 4. We are now going to go over problems 31 to 40 on your semester 1, Algebra 1 final review. Here on our first question, you can see 31, we're looking at the first 5 terms of a sequence. That means that we're going to be using sequential functions, and it's going to be those explicit and recursive formulas that I know we love so much, but we're going to be okay. So if you look down here, you can see that even though this formula, our explicit formula, is going to be the one that these functions are set up in, they say f of n because it's still just a function, so it's not going to say a of n. Okay, but because we've seen this before where it says a of n, or a sub n is, and it has the n there with the number, we're going to actually use this formula to help us solve. So in order to use this explicit formula, we are going to go ahead and start with our first term, which is a1. That's 29. Okay. I am then going to take a look at my pattern and see what is the difference. So you can see here that we are taking away 4 to get from 29 to 25, 25 to 21, and so on. That means that my difference, or D, is minus 4. I am then going to just distribute that negative 4 inside my parentheses, and I will get, okay, I'm going to combine my like terms here, and I'm going to get 33 minus, let me undo that, minus 4n. And if I use the commutative property there and flip that around, you're going to see that my answer is A. All right, on number 32, we have another function problem. So an exercise program begins the first week with 30 minutes of daily exercise. Each week, the daily exercise is increased by 5 minutes. Which function, explicit formula or recursive formula, represents the number of minutes of daily exercise in the nth week? Select all that apply. So we know that it's going to be more than one, and this is similar to that other problem where we had the different formulas for linear equations and we had to pick one of each kind. We're going to kind of do that. We're going to make sure that we pick a function, an explicit function, and or a recursive formula, explicit formula, that's going to match our situation here. So we might have to change them like from explicit to recursive or vice versa. So the information that they give us is that it begins the first week with 30 minutes, which means this is going to be my first term in my sequence. Okay, so A1 is 30. Each week the daily exercise is increased by 5. So my difference from one term to the next will be a positive 5. Using that information, I'm going to fill it into my recursive and explicit formula. So since we just did explicit above, let's go ahead and write that one out. So I'm going to have my first term plus n minus 1 times my difference. Now if I look through here, let's see if any of these match, right? So here I have 30 plus 5 times n minus 1. That right here, these guys look very similar. It's just that my distributive property, the 5's on the other side, so I know that that one is correct. Okay. Then when I come down here, I'm going to actually solve this and see, solve this equation and see what I get. So I'm going to get 30 plus, and we're going to distribute that 5, n minus 5. So this one would be 25 plus 5n, or 5n plus 25. So again, we're going to look through here and see 25 plus 5n right there, J. That also works, okay? That also means that I could probably cross off a couple of these because they are not correct. So what I'm looking for now is I'm starting to look at like a recursive formula, okay? Or, so like that guy's in recursive and this one is just a regular old function, and we want to see if any of these match. So because our problem above replaced the a of n with f of x, we know that this could also be a possibility, or if it's f of n. So if I look here, the one that would match what I have would be k. And then if I'm looking for recursive, I know that a1 is my thing there. My recursive formula is a of n equals a n minus 1 plus the difference, which is in this case is just 5. So this guy right here, h, is also true. So it looks like we have 4 possible answers. All right, 33 is another function question, but this time we're looking at a system of functions or a system of linear equations. In this case, the functions f of x and g of x are graphed below. So you can see them labeled. F of x and g of x are these lines. Approximate the value of x when they equal each other. F of x equals g of x. So I want you to think, if I knew the equations for this line, then I would be setting up these equations equal to each other. So let's just pretend that, nope, let's not use the y because we're using functions. Come on, eraser. There we go. Let's just assume that g of x is some sort of slope-intercept equation. Hold on a second, sorry. Okay, and f of x is also some sort of equation. So I would, if I knew my equations, I would just set them equal to each other. And then I would solve for x. But because we don't know what the equations are, I'm going to have to just use the graph here, okay? And because it says approximate, that tells me that I am just estimating. So I'm going to use this point right here, and I'm going to find its approximate location on x. I'm going to use my answer choices here, A, B, C, and D, and I'm going to look at which ones make the most sense. So we know that this is less than -2, but greater than -3. Okay, which means that it's not going to be positive. Okay, it is not going to be -1.8, and it's not going to be -4. So B is the only one because this looks like it's about -2.5. And that's it. B is our answer. All right, number 4, we are looking at equations. So this one has a lot of work, as you can see, that I did out to save some time. We've got 4 equations here of 4 lines, and they're all in different formats. We want to know which 2 equations will form a system with no solutions, meaning we're looking for something that's going to give me a false answer. We're looking for something that is not the same as our other line. They're not going to give an answer. They're not going to give a infinite. It's going to be false when I set them equal to each other. So we're pairing up lines here in our answer choices, and we have to figure out which 2 are false. So automatically, by looking at my information here, I can see that this line right here is going to be a slope of 1/3, and this line right here, which is line 1, is also going to be a slope of 1/3. Because they have the same slope but different y-intercepts, those lines will be parallel. And lines that are parallel have no solution. So 1 and 3 are lines that are going to have no solution. So that's going to be D. You could set each of these equations equal to each other and solve, but I kind of use the graphing method to solve this one in my head. All right, we have another systems of equations questions here on 35. We're talking about the graph and a table below show the values are given of they represent 2 linear equations in a system. So we've got linear equation for line A and a linear equation for line B. And we want to figure out which of the following is a solution to the system. Meaning if I put the 2 together, okay, what is my answer? What's my solution? So because they give us a graph and a set of points, I think the easiest way to do this is just to graph the points of line B on to the graph of line A. So we can label this line A, and then we can see where they meet. So I would do -1, +6, which is way up here, 0, 4, which is right under 5, and then 1, 2. And then using a handy dandy, line tool, I'm going to go ahead and connect my lines so that I can find the connection point. Oh, that was right here. So again, if I connect my lines without my line tool, since it disappeared on me, we're going to find our connection right there. And so that answer is going to be positive 2, 0, which is A. All right, on question 36, we need to figure out which of these 4 equations would we need in order to have an infinite number of solutions for this system right here. So if you remember, infinite number of solutions means that it needs to be a true statement, meaning this side needs to be exactly the same as this side. So if this is my equation for my first system, y equals x plus 1, I need to have the same slope and the same y-intercept in order for it to be infinite. Okay, so I'm going to go ahead, get rid of these so you can see it better now. So I'm going to go ahead, and what I did was I went and solved, put them all into the same format, which is slope-intercept format, so divided by 2 on each side, and rearrange this from kind of standard form into slope-intercept form so that I can compare. And as you can see, these problems over here do not have the same slope or y-intercept. B is pretty close, but that y-intercept is not correct, so these lines would be parallel. These would be no solutions. So A has to be my answer here. All right. Number 37, we are looking at 2 different linear equations again, a system. We have line A, which is given in an equation, and line B, which is given in a table. You could choose to write an equation for this table so that you can then set them equal to each other so that you can find the solution to the system. But I do think it's going to be easier to graph. So if you take one of the graphs, I have one down here that is, I might just copy pasted it from previous in your study guide, which you will be provided on the test. You could graph these 2 things, and that's what I'm going to do right now. So I'm going to scroll this down a little bit. We're going to graph the line -4 is my y-intercept, 1, 2, 3, 4, and then my slope is -3 over 1, because remember that's really over 1. So normally I would go down 3 and to the right, but instead I'm going to go up 3 because I kind of ran out of room on my screen. 1, 2, 3 this way. Okay, you can see that my slope is still a negative slope. 1, 2, 3 over. So here's kind of my line here. You can kind of see it going 3 like that a bit. I obviously would recommend that you use a ruler, but it's hard to do on a computer screen. Okay, then over here I'm going to graph the points that are in my table. So let's just start with the ones I can see. We'll switch to a different color. I'm going to use +1, -2. I'm going to use +2, -5, which is going to be way down there. So let me move this a little bit. Okay, -5, 2, 4, 5. And then my other point is -1, 4. Bloop. Come on. -1, 1, 2, 3, 4. Okay, and then I would have to connect those right there as well. Okay, as you can see between these points right here and here, my slope is actually the same. So because my slope is the same and my y-intercept is different, that means that these are going to have no solution. So for 37, your answer is D. Number 38, we're solving for systems of equations again. In this case, we are going to use elimination because our equations are set up in standard form, so it's going to be easier. We are also only looking for the x-coordinate, so if I can eliminate my y's, then I know that I can find x a lot easier. So what I did was I multiplied just my top equation by 4 so that I could eliminate my y's. So over here, when I did 4 times x, I got 4x. 4 times -2y is -8y. 4 times 5 is 20. Then I added my equations here, and so my 8y's, my y's were eliminated, and I got 7x equals 21. Divide by 7, and you get x is 3, which is B. Okay, we're just going to do this last one here because I'm running out of time. So take